Alright, making a video supplement to the last video about the ellipse, and as an explanation of a mechanism that would create the prospect of perpetual motion, in the sense that once you established a velocity in a frictionless environment, that you would maintain your velocity. And why that would happen, why would your atoms keep moving? And the fact that they'd have to have a shape changed for that to happen. I got it backwards, of course. That happens. Well, it shouldn't happen, but it happened. It is draft science, and I'm working on it, piece at a time. So I guess a better way to do it would be, I should have used a triangle or some other kind of mechanism. But if you did think of an atom as being a surface that a force is going to affect, like a line, and then you just took the idea and just pushed one of those lines out, by just force. You either smashed one side in or you pushed the other side out. So you just, if I created a triangle, so I opened the bag, so to speak, you can see that from a triangle's point of view, you spend a lot less time going from left to right at this bottom, because it's a straight line, and a lot more time going. You would be affecting space in this area a lot longer. So the time curve would exist. It'd be much heavier on this side, because you're spinning a triangle. You can obviously see it'd be a much longer line. So if these were all equal speeds, you'd be twice as much time. If this was a circle and you were going around this triangle as a circle, you could see that you would spend twice as much time on this side of the triangle than you would on this side. So you would be going in some direction related to this direction a lot longer than you would be doing it this way. So even though you're eating the same amount of space technically per gulp, and there's a lot less smaller bites here, these are bigger bites you're taking all the time. The fact is, you're spending twice as much time here, and so you're going to have more opportunity to eat, let's say. So if there was a stream coming through, and the stream was equal, coming both ways, you're obviously going to have more chance of interacting with a stream on this side with a triangle than you would have opportunity to interact on this side, because it's a time issue. Time becomes important. Distance becomes important in terms of affecting which way you're going to be influenced by the stream. One stream is going to be more influential based on how much you're exposed on that side. So the exposed side is going to have more possibility of interaction. So for the sake of this argument, it doesn't really matter which way you turn this triangle, or which way, whether you say that there's always this pressure, and you could argue that the stream is going to affect the angled part, the part that's out further, more. Get back to the ellipse idea, that it's going to have more chance of impacting, which means you'll go in that direction because you have more chance of impact. Or you could do it the opposite way and say if it's eating something, it would eat more of it. So let's just go with the stream idea, that it's all even stream gravity, and that it's only going to affect the surface that it comes in contact with. So instead of making my argument that the gravity goes through and hits the outside edge and gets deflected, let's go back to just the more intuitive idea that it hits this first surface and flattens it, sort of creating the triangle effect. And that as it flattens this surface by hitting it, the idea is now it's more exposed on this surface, on this counter surface, the triangle side. That would be inverted, so I better stop. I better quit while I am behind. Yeah, it can't be flattening, it's got to be pointing it by affecting it. So it's not flattening it by interaction with it, it's creating the point by interacting with it. So you figure the gravity is creating a syndrome of narrowing, and in narrowing it is creating See, now I'm going to get myself in the same trouble again. It doesn't really matter. I think you get the idea that all we need is a model that changes the disposition of the fish, the thing, the school of fish actually, but it's a fish for the purposes of this argument. It's behaving. It's being considered a kinetic object that's going to have directional information exchanged with gravity. So the gravity is really exchanging information with the individual pieces, but the net effect is an effect on the overall system and causing it to not only move, gain acceleration, but to maintain that acceleration it has to change it in some permanent way. There has to be some kind of structural change that forces it to keep going, that forces it to keep spiraling in a direction, or whatever it's doing. However the mechanism is, I'm trying to come up with a way of describing the fact that as you change its shape, you'll change its reactivity to the environment. And obviously there's a consistency between the direction of extra gravity. So you have extra on this side, 4, and only 3 on this side. So there's extra gravity on one side because an object is blocking the gravity. The extra gravity is creating a shape change. This is all a shape change. And that change, whatever it be, is creating the impetus for the thing to keep moving in the field, even when the field is neutral. So even when the field becomes neutral, 4 and 4, it's still going to move in one direction because it's more vulnerable to the field, in one direction because of the shape change. Alright, well that's a safe way to do it. Obviously there's a lot of moving parts here and it does get a little difficult. But anyway, I just thought I'd make that correction before colossal snowstorm and all that shit. I don't think I need to add anything else. So, yay, a short video for a change. Yeah, I just have to, it's just something I have to spend more time on because obviously my brain is not making the best out of this conceptually. But the point is that gravity changes the structure of your atoms, and in changing their structure creates a mechanism where they will continue to want to dig in the direction of the gravity, even when the gravity is removed, if there isn't some other force pushing them, stopping them, resisting the velocity.